into the components of a time series data set, right? Now, so time series components, there are four main components that make up your time series, which is the long-term movement or trend, the short-term movements, and you can then have the random or irregular fluctuations. I know I mentioned three, but that's because the short-term movement composes of two, which is the seasonal variations and the cyclic variations. But let's get through it. So long-term movements, this is essentially the overall movement of the time series value to either increase or decrease during the range of time. Sometimes they can be known, there's no upward or downward change, it just remains stationary during this long period of time. So during time series analysis, it is common to observe either an upward or downward trend of the measured variable. However, it's just like I said just now, it's possible for there not to be either, right? So then you have your short-term movements, right? And the first one that you normally get and deal with, you'll see a chart of it now, as a seasonal variation, right? Seasonal changes. And essentially these are periodic temporal fluctuations that show the variation. And these variations usually repeat themselves in a period less than a year, right? So seasonality is affixed to a known period, right? So it's fixed to a known period. And that is the difference between seasonality and cyclic variations. One is fixed to a known period, the other is not fixed to a known period. So predominantly the variation is present in time series where data collection occurs hourly, daily, weekly, quarterly, and monthly. All right, so think about events such as holidays and festivities during Christmas. Every time Christmas or before Christmas, you see a spike in purchase just before the holiday. Or if you, let's say you are in South Africa, you're watching this from South Africa, and it's time for Easter. So therefore, during that April period, you will see, let's say you're a toll worker, you work at the toll gates, you see a spike in traffic or spike in income coming through the tolls during that Easter period break, where people travel across the country to either their homes and take that 4-day weekend. All right. Or you could think about climate seasons, right? So if you're a retail company during when it's I think that's in between May, just before May, you see an increase in purchase of maybe heaters, right? So that will always happen every year. So that's an example of a known fixed time period, right? And then you have cyclic variations, right? So these are recurrent patterns which exist in the data when we see rises and drops, right, of an upward trend or a downward trend, and it is not fixed during a period. So a complete period is a cycle, and cycles do not have to have a predetermined length of time, even if the fluctuations are usually longer than a year, right? And that's cyclical change. And the last one is random or irregular noise, or irregular fluctuations, sorry, but it's usually referred to as noise, right? So these are usually referred to as noise because they are uncontrollable, unpredictable, and erratic. Things such as earthquakes, wars, floods, and other natural disasters which cannot be predicted. So the other three, long-term movement, short-term movements, which include seasonal changes and cyclical changes, they can be predicted, right? But however, the irregular or random fluctuations cannot. So the other three are sometimes referred to as signals, and then the random or irregular fluctuations is referred to as noise. So your duty as a data scientist, right, you would have to identify each component and how it contributes to the time series data that you have, and you would now use this to now build an accurate model, right? So the first step when you start doing your time series analysis just before your forecasting, you would now, it was recommended actually to decompose your observed time series into these four components in order to recognize and measure their effects on the overall observed pattern, right? This is usually the first step in building a forecasting solution, and it allows you to understand the important concept required to making time series prediction, and that is called stationarity. So when you so here it is. So when you decompose your time series, you end up with these, right? So this is your observed trend, and then it's now decomposed where you can now see there's an upward trend in here, and you can see the seasonal and short-term seasonal effects and cyclical effects. And here is just, you can just see the noise. You can just see the noise that we can't predict. Okay, so this is from Python plot. It's a Python plot, and it's gotten from Python library called StatsPy, but we'll go through it. Okay. So stationarity, right? So what is stationarity, right? So when you look at this time series on over here, you can see there's an upwards trend. I just want you to take a mental picture of that and like discuss about stationarity. So what is stationarity, right? So stationarity is essentially used to analyze whether statistical or parameters of a time series change with respect to time or not, right? So the stationary time series means that the mean or the variance of the time series remains constant with respect to time, right? So if you look here, the variance and mean are not staying constant. There's an increase there. So when it remains constant, right, they're easy to analyze due to the fact that the property of the data distribution is not a function of time. So the statistical parameters are not changing at each specific progressive time point. So we have mainly two types of stationarity. You'd have the strong and the weak, and essentially the strong is just where you have statistical parameters that do not change, and the weak is where you would see like the mean and the autocovariance functions do not change with time. Right, so like I said, it's a hindrance to accurate predictions because non-stationary time series data is more difficult to predict values, right? Because your statistical parameters are a function of time, so you would have to capture that change of your statistical parameters. So it's a lot more difficult, and so as a data scientist, we have to now start performing some transformations in order to make your data set stationary, right? So yes, as we're talking about, so you would have, there are cases where the time series has unknown underlying like nonlinear relationships, right? And you can't use the classical methods that that I spoke about earlier, such as autoregression, exponential smoothing, moving averages, or autoregressive integrated moving averages, otherwise the Riemann modeling, right? So you can't use those to capture the underlying non-linear relationships. So, however, most of the time, what you will see is that most of the time, what you will see here is that economic time series, so like price change or stock returns or something, they exhibit non-stationarity, and even after seasonal adjustments, you still see trends and cycles and other non-stationary aspects. Just picture that, right? So it makes it quite. That's why you need like complex stochastic models that will be able to predict these price movements. All right, considerations for forecasting solutions, right? The inputs and outputs for your forecasting model, right? So that's essentially, okay, what is the data that I have at disposal and what am I trying to predict, which is your output. And when I say output, how far, what is your time horizon that you are looking at? Is it next quarter? Is it an hourly? Is it a daily? Or is it a weekly? So then you have to make those into considerations. The level of detail for your forecasting as well is important. Time horizon. So you have your time series data, right? That is just essentially the process of how it goes. You have your time series data, and then you feed that into a forecasting model, and that is going to predict future values. All right, guys. That is the end of the slides. Thank you for staying on and listening. We will now move on to the Python section, and I will walk through, we'll do a coding exercise together, and I'll speak about how you perform time series analysis and some of the tools that you use or need. Thank you, guys. See you there.